Okay, quick recap. So what we're learning today is a scalar product, also called the dot product or the inner product. And basic idea, whether you have a two-dimensional or a three-dimensional vectors, is you multiply the corresponding ones. So 3 times 2, that equals 6. 1 times 5, that equals 5, and add them up. So here you do 1 times 3 is 3. 2 times 2 is 4. 3 times 1 is 3. Add those all up, and you would get 10. The answer you get is just a number. And another word that we've learned for number is scalar. So that's where the scalar part of the name comes from. So it's called dot product because there's dot in between them. Sometimes it's called a scalar product because the answer is a scalar. And the inner product we'd have to look up to figure out where there's the application that uses the word inner. The dot is inner between them? I'm not sure. We'll figure that out. So here we go. Scalar product of the vectors.
We weren't laughing at your joke, by the way.
No, I could tell because it was, I don't even think I tried to make a joke.
I didn't even hear it. Excuse you coming. I can't speak for all of us. Also, Mr. I have to leave the tournament service. I gotta go kiss a girl.
Were you able to get, so did you get -4?
Yes.
Awesome. Three-dimensional one. Have you done this one already too?
Yep.
All right. 2, -5, and 3, dot product with 4, 1, and -7. 8 plus -5 plus -21. -18. Okay, so why do we have the scalar product? And there are some interesting things that happen, but here are some properties first. Some things you're allowed to do. So again, every time that you invent some or create some math, because there's a reason why we want to use a scalar product, and we're going to see later why we're going to use it. Every time we have it, we want to see what kind of properties hold. Because there's some basic math properties we've learned all the way along, like 2 times 3 is 6. 3 times 2 is 6. Does that work for the dot product? Because it didn't work for matrices.
It does. It says under A.
It does under A. Yes. Woo. And you learned if you multiplied 3 things together that it didn't matter the order. And that's the case as well for vectors and the dot product. And the dot product with vectors, distribution works. You can dot product one and dot product the other. And there is, if you have a vector that's all zeros, and you dot product a vector with all zeros, you would have a bunch of zeros that you would then add up and still get 0.